In this video, we'll derive an equation for the electrical potential energy. So work is done on charge Q to move it from point A to point B in the electric field of this charge. So the infinitesimal work done by the electric force on this charge to move it an infinitesimal distance ds is equal to the dot product between the electric force and the displacement vector. And note that we can resolve this displacement vector into radial and theta coordinates. Okay, so we can use polar coordinates to represent the vector. And therefore, the work is simply equal to Fe dot dr, which is the component of ds in the radial direction. And this is equal to the magnitude of the electric force by the magnitude of the component of the displacement vector in the radial direction by cosine theta, and the angle between these two is effectively 0, so cosine 0 is 1. And therefore, if we integrate both sides, we have the integral of dw is equal to the integral of the electric force over r. And we integrate from point A to point B. So we have the work from point A to point B, and we're integrating over r from point A to point B. So what we have is Ra to Rb. And recall that the magnitude of the electric force is equal to the charge Q by the magnitude of the electric field at that point. So what we have is Q multiplied by Q over 4 pi by the permittivity constant, and that's multiplied by 1 over the radial distance squared to that point where the charge is. And we're integrating over r. And this gives us the total work done on this charge as it moves from point A to point B. And now if we evaluate this integral, so we take the constants outside, so Q by 4 pi epsilon naught, and we evaluate the integral of 1 on r squared, so that will be minus 1 on r, and we evaluate this from Ra to Rb. And therefore what we get is Q by Q on 4 pi epsilon naught, and I'm going to put that negative sign outside, and what we get is 1 on Rb minus 1 on Ra. And this is the work done by the electric field on that charge as it goes from A to B. And therefore the change in potential energy as the charge moves from A to B is equal to the negative of the work done, and therefore our change in potential energy becomes positive here. And I'll see you in the next video.